All right, Bio 202 Ninja. Here we go. So, summarize what we did before. Proteins, big string of amino acids. Take each amino acid, deaminate, send that to the liver, urea cycle, make urea, eliminate in urine. Leftover CH and O can be made into keto acids and then turned into acetyl-CoA. Let's start talking about carbs. Let's start out here. Let's talk about dietary carbs, all right? So, remember what are carbs again? You know, what are the main carbs from your diet? Starch, all right? Plants, remember, store glucose as starch. Animals store glucose as glycogen. So, mostly what's going to happen here, when you eat carbs in your diet, how are they going to show up? Well, you can either get them, through whole grains, rice and wheat and quinoa. Or, you can Girl Scout cookies and ice cream and alcohol. But one way or another, you're putting glucose into your body, all right? So glucose comes in, and then glucose breaks down into this thing called glyceraldehyde 3-phosphate. So remember, what's the chemical structure of glucose? C6H12O6, 6 carbons. So we break it down into 2 3-carbon compounds. Glycerol 3P, the Calvin cycle, the dark reactions. Even though they're not really in the dark. Then G3P converted into pyruvic acid, all right? And then pyruvic acid can be transformed into the magic molecule of metabolism, the M-cubed acetyl coenzyme A, which is just the most versatile, wonderful, amazing thing in the universe. And then acetyl-CoA, what it does is it hands off an acetyl group to the citric acid cycle. And oh yeah, now we're cooking with gas. Remember the Krebs cycle used to be called citric acid cycle? Remember oxidative phosphorylation, the electron transport chain. And what do we end up doing? Yes, we end up creating the molecule of life itself. It's alive. ATP, plants, animals, slimy things. Almost everybody uses ATP. The molecule of life. Oh my God almighty. Oh my God. So what happens here again? Carbs. This is going this way. And we have a name for this. We have a name for taking glucose that we're getting from the diet in this case and turning it into ATP. Remember, we get 2 ATPs for every 1 molecule of glucose. We're talking about glycolysis here. That's what's happening. This is glycolysis. That's what this green pathway is. So the green pathway starts up here. We get glucose. We break it down into G3P, pyruvic acid, acetyl-CoA. Plug in acetyl group into the citric acid cycle, and damn if we can make an ATP. Yes, we can sing and dance and laugh like this. Come, let's all virtually hold hands and sing Kumbaya. We have made ATP. So that's pretty damn cool. Now, interestingly enough, there's another pathway here that we have talked about. So in this pathway, we can take keto acids, watch this, and we can turn the keto acids into acetyl-CoA, as I said before. Acetyl-CoA can be converted back into pyruvic acid. Is that the cat's ass in the moonlight or what? And then pyruvic acid, which is actually a keto acid. So we can turn that back into G3P. Then we can turn it into glucose. And then what have we done? Oh my God, what did we just do? Look at this. We started with proteins over here. We got the amino acids, we deaminated, we took the CHs and Os, we turned them into keto acids, we made it into acetyl-CoA, into pyruvic acid, G3P, glucose. Oh my God! What manner of sorcery is this? We started with proteins and we made glucose. We started with proteins, we made glucose. There's a name for that, remember? Of making this pink pathway. Let's just draw it up. It's not really going anywhere, but we'll need to put the name in someplace. So remember, what is it called to make glucose out of non-carbs? Yes, gluconeogenesis. That's the pink pathway. The pink pathway is taking a non-carb and converting it into glucose. All right? And what would we do then if we make extra glucose? Where are we going to put extra glucose? Where are we going to be able to store the extra glucose? Remember, we got the carbs in the first place mostly from plants who store glucose as starch. How did animals store glucose? As glycogen. So that's what this pathway is going to end up. That's where it can go. So we can take anything, we can take non-carbs, turn them into glucose, and if we get too much, that's gluconeogenesis. New, Genesis, make glucose, make new glucose. And if we get extras, we store it as glycogen. So look at how that works. Oh my God, we have seen a linkage here between the carb and the protein metabolism that allows us basically to be very versatile in what we're doing. And what really, who is the big player? Who is the MVP in this whole thing? M cubed, buddy. Acetyl-CoA, so incredibly versatile, allows lots of things to happen. So what we're going to do now is we are going to go next. We're going to finish up this movie. Next we're going to look at lipids. That's our third big metabolic pathway. So stay tuned.